Antimatter is the most expensive substance on Earth, having a price tag of $62.5 trillion per gram. That's almost 3 times the GDP of the United States of America. There are 2 reasons why this thing is so expensive. Firstly, it's pretty challenging to produce, and secondly, it's even harder to store. Just 1 gram of matter and antimatter collision can create an explosion, more powerful than a nuclear bomb. In 2011, scientists created a record of holding antimatter for 15 long minutes. The total amount of antimatter artificially produced by humans is just 20 nanograms. But what is this antimatter? How did we come to know about it? And most importantly, why are scientists so excited about it? To understand the origin of antimatter, we need to go about 100 years back in time. The first 30 years of the 20th century were a golden era for physics. 3 significant theories took birth in this era. The first was the special theory of relativity, that describes physics at high speeds, close to that of light. The second was the general theory of relativity that describes gravity in a much better way than Newton's theory. Finally, the third was quantum mechanics, that explains the motion of tiny particles that make up the universe. Soon, scientists realized that something is missing in quantum mechanics. To accurately describe the behavior of small particles, they need to unify it with the special theory of relativity. After years of work, physicists came up with an equation that finally connects these 2 theories. This equation is known as the Dirac equation. But something did not seem right about it. This equation hints at the existence of exotic matter known as antimatter that has negative energy. How could something have negative energy? Physicists had no idea if such a thing could ever exist in the universe. Just 5 years later, the discovery of antimatter was announced. It was a breakthrough in physics. For almost every particle, there exists its corresponding antiparticle with an opposite charge. So if an electron is a particle with a negative charge, a positron is an antiparticle having the same mass but a positive charge. Renowned physicist Richard Feynman said that antiparticles are just particles that are traveling back in time. Moments after the Big Bang, matter and antimatter were created in equal quantities. But due to some unknown process, matter particles outnumbered antimatter. In 2018, while searching for antimatter, scientists recorded something strange on the International Space Station. Their detectors recorded 6 particles of antihelium. This substance had been produced in labs on Earth in 2011. Back then, scientists said that if they ever detect antihelium in space, it must be coming from the nuclear fusion inside a star made up of antimatter. But theories also hinted at cosmic rays behind the detection of antihelium, casting doubt on the existence of antistars. Now, researchers have examined 10 years of observations from the Fermi Gamma Ray Space Telescope. The catalog contained nearly 5,800 gamma ray sources, normally pulsars and black holes. Amongst these, there are 14 unique sources that possess energies that are generally an outcome of matter-antimatter annihilation. And if these observations are confirmed, there's a great possibility that the stray antimatter detected in 2018 could have been shed by antistars. Statistics say that the Milky Way should have 1 antimatter star to 300,000 normal stars. If they exist, antistars would fuse antihydrogen into antihelium to produce light, and thus would look reasonably ordinary. This makes their detection very difficult. If antistars are proven to exist, they will alter our view of cosmology, astrophysics, and particle physics.